Welcome to qnawire.
Hi, so over here we have the following reaction in which we're going to employ the small x approximation. In this case, we're going to generate C2H2 plus 3 of hydrogen. Everything here is going to be in gas phase, and we're told that the value for Kp is equal to 1 times 10 to the minus 5. The information that is given to us is that the initial pressure, whenever we do our ice table, in this case we're going to employ the partial pressures of each of the compounds. The initial pressure is going to be 10 atmospheres of methane gas. So over here we're going to get 10 atmospheres, 0 and 0. So the small x approximation, what it means is that the amount of change, the amount that is going to react over here, we're going to call it minus, I'm going to use minus 2x because I'm multiplying by the stoichiometric coefficient of CH4. In that way, over here we're going to produce plus x and plus 3x. Otherwise, we would have to take a factor of 1/2 and 3/2 if you want to just use directly a value of x. So at equilibrium, we're going to get 10 minus 2x, x, and 3x. So now what we're going to do is write down the value for Kp. Kp is going to be equal to the pressure of C2H2 times the pressure of hydrogen to the cube divided by the pressure of CH4 squared. If we replace the values that we found from our ice table, what we're going to get is x times 3x cubed divided by 10 minus 2x squared. So the small x approximation, what it means is that the value of x is going to be much, much smaller than the value for, in this case, the initial pressure, that is 10 atmospheres. In most of the problems, you're going to see that x is going to be much, much smaller than the initial concentration of a compound. In this case, since we're dealing with gases and Kp is given to us, it is going to be with respect to pressure. Under this approximation, what this means is that 10 minus 2x is going to be approximately equal to 10 directly. And we can continue and directly solve for x. So, using this approximation, the value for Kp now becomes approximately x times 3x to the cube. So, we're going to have 27 x to the 4, and on the denominator, we're going to put directly 10 squared. So now our equation is going to be 100 times the value for Kp divided by 27 is going to be equal to x to the 4. Thus, the value for x is equal to 100 times Kp divided by 27, all of this to the 1/4. Replacing the value for Kp, which was 1 times 10 to the minus 5, we get a value of x equal to 0.078 atmospheres. Now let's verify what this value of x means. X is going to be the pressure of C2H2 directly. So the pressure of C2H2 at equilibrium is going to be equal to 0.078 atmospheres. You want to know, and just to check if this approximation was correct, what we can do is compare the value of 10 with respect to x, and as long as we have that x is lower than 10% of 10 atmospheres, then we're good to go. In this case, this is going to be quite true. Actually, the value for 2 times x, the value of 2 times x, the quantity that we subtracted over here, is going to represent only a 1.56% of the initial pressure. So the approximation is valid, and this is going to be your final answer. Additionally, since you know the value for x, for example, you could find the values for the equilibrium pressure of CH4 and for hydrogen, because you have them in terms of the value of x. So with that, it would be all. Thank you very much and have a good one.